Okay, let's look at a numerical example of computing the capability index. So suppose if you have an insurance processing claim that has a process mean of 209 minutes to process the claim, and the standard deviation is 0.516 minutes, and suppose if the specification calls for 210 minutes plus or minus 3 minutes. Plus or minus 3 is the tolerance, so 210 plus 3 gives you the upper specification limit, 210 minus 3 gives you the lower specification limit. Remember, you have to distinguish between control limits, control chart, and the capability. So here we are assuming that the process is in control, because if the process is not in control, you have to go back and do that first. Now, the very fact that we are trying to compute capability index, we are assuming that the process is in control. So now the upper specification limit minus x bar divided by 3 times sigma, and then x bar minus the lower specification limit divided by 3 times sigma, and you calculate that out, and C sub pk comes to be 1.29. Okay, is the process capable? For that, you have to ask yourself, process capable at what level? Okay, if it is at the 3 sigma level, then you would say yeah, because for 3 sigma level, C sub pk of 1 is good enough. But that is rarely the case. The normal, the default value, okay, unless otherwise specified, you must always assume that you would need at least a 4 sigma level of capability. So which means C sub pk must be at least 1 and 1/3. Now 1.29 falls short, so therefore this process is not capable. Okay, well, it should be process is not capable. Okay, now how can we make this capable? Okay, there could be two problems why this process is not capable. Okay, one is the central value, the target, remember, is 210, right? So that's the midpoint, 210 plus or minus 3, and this 209 is probably not, it's too far away from the mean. Okay, so that could be a problem. Okay, or it could be that this variability, process variability, is too large. So either the x bar value is too far from the target, or the standard deviation is too large. Which is it? Which is the problem? So we have another number that we can calculate to see whether the variability is small enough or not, and that is called process capability ratio. Okay, so this is should be called ratio, and ratio is called C sub p. Okay, so C sub p, okay, the ratio is upper specification limit minus lower specification limit divided by 6 sigma. So this does not use the process x bar, it only uses the lower and the upper specification limits, and the same rule applies. Okay, if it is equal to 1, then that is capable. Well, I shouldn't say capable, because this is not about capability, it is about the variance, whether the standard deviation is small enough or not. So 1 would indicate it is small enough if all you're interested in is a 3 sigma level of performance, which is usually not the case. You will need at least a 4 sigma level of performance, which means you need 1 and 1/3. If you want 6 sigma performance, then C sub p should be equal to 2. And here, when you look at the C sub p value of 1.9, you see that it exceeds 1.1 and 1/3 very easily. So that means for the 4 sigma level of performance, this process standard deviation is great, no problem. So the issue here in this process is the centering, the target. The target of 210, the actual x bar is 209, so it should be closer to 210. One might ask, is it not better for insurance claims processing to have less time? So 209 is better than 210? Well, that could be, but it could be that if it is too far away from the target, maybe you're not spending enough time in the claims to make sure that it is properly processed. So the target, for whatever reason, is established as 210, and you want to be as close to the target as possible. So the way you would proceed at this point to make the process capable is that you will not try to attempt to minimize the process standard deviation, because the C sub p tells us that it is sufficiently small. You don't need to reduce that anymore. So the problem is really in the centering. So you should try to see how to make the process average closer to 210. Okay, so here are the possibilities for the C sub pk value that you're likely to encounter. Remember, once again, C sub pk is what determines whether the process is capable or not. You want that to be at least 1 1/3. Okay, C sub p is only about the variance of the production process. So if these two are the specification limits, lower and the upper specification limits, now a process that has this kind of shape with midpoint here, that is the midpoint exceeds the upper specification limit, then you will end up with C sub pk being a negative number. Now, if it is exactly like that, okay, the midpoint falling exactly on the upper specification limit, you will have a C sub pk of 0. So now if it is like this, the midpoint being somewhere in between the lower and the upper specification limits, then you will have a value between 0 and 1, okay, with the tail, some part of the tail outside the limits, either side. Okay, so if it is exactly, okay, if the two ends of the process is exactly coinciding with the control limits are coinciding with the specification limits, you will end up with a C sub pk of 1. Remember, that indicates that the production process is capable at the 3 sigma level, because the 3 sigma fits into the specification limits exactly, and that's no good. You don't want that. So you want something like this, where 3 sigma fits well inside, but actually if you extend it 4 sigma, okay, that coincides with the lower and the upper limit, you will have a C sub pk 1 1/3. But if you extend 6 sigma, and if 6 sigma limit coincides with the lower and the upper specification limits, then you will have a C sub pk of